All right, so this video, I'm going to go through the high-level rational functions, but I'm only going to do number 1, and then I'll do separate videos for 2, 3, and 4. These can get a little bit on the long side. I don't want a video that's, 25, 30 minutes long if I can keep them a lot shorter. So we are going to graph these just like we graph the other ones, but in some cases we're going to have to deal with other asymptotes versus horizontal asymptotes. So we'll get into that. All right, let's get into number 1 here. We need to first see if we can factor and cancel. So numerator-wise, we have a GCF of 2, x minus 3 is left. X squared minus 2x minus 3 factors into x minus 3, x plus 1, which leaves me with x minus 3's that I can cancel out. And the simplified version is going to be 2 over x plus 1. So I'm going to find all of my key characteristics here. So x-intercept, I'm going to take the numerator, set it equal to 0, and my brain officially hurts writing that down because 2 does not equal 0. 2 will never equal 0. So because I cannot make 2 equal to 0, there is no x-intercept. All right, y-intercept, I'm going to take the simplified version, and I am going to make x equal to 0. And I'm going to reduce that, simplify it, solve it, whatever you want to say. So 2 over 1 is 2, which gives me a y-intercept of 0, 2. Vertical asymptote. Take the simplified denominator, set it equal to 0, and solve. So x is equal to -1. Now we've got to figure out, do we have a horizontal asymptote or an oblique? And remember, we had the rules in the last video on what the degree is. So I want to look at the simplified version, and right now I have degree 1 in the denominator, and since I have no x's in the numerator, it's called degree 0. So clearly the denominator has the higher power, which means I have a horizontal asymptote as y is equal to 0. If I have a horizontal asymptote, I cannot have an other asymptote, so there's none there, okay? Any holes in the graph? The answer is yes, because we had a factor that we canceled out. So to find the hole, the discontinuity, take the factor that you canceled, set it equal to 0, solve for x. So that gives us half of the discontinuity, or the hole. Want to find the other half, so we're going to take that x value, put it into the simplified version. Okay, so we get 2 over 4, which is better known as 1/2. And now I'm going to take this information and see if I have enough information to do a full graph or if I need to find any extra points. All right, now the graph for this is below where all this information is, so I'm going to be kind of scrolling back and forth. So let's see, I've got y-intercept of 0, 2. All right, so 0, 2. Vertical asymptote is x is equal to -1. So I'm going to put the vertical asymptotes in, or the asymptotes plural, in with some dotted lines here in highlighter, but I think I want to shrink it down a little bit so it's easier to fit on the graph. So x is equal to -1. So there's one of my vertical asymptote, well, my only vertical asymptote. And then I had y was equal to 0 for the horizontal. So that's going to be the x-axis itself, which kind of explains why I don't have an x-intercept here. Now, that doesn't always happen, but it does explain a little bit for this one. And we have a discontinuity or hole at 3, 1/2. So I'm going to go to 3, go up to positive 1/2 here, and put in that discontinuity. Now I have a small problem, because clearly I can draw this curve on the right side. Okay, well, maybe I can draw the curve on the right side. Okay, I have the points to draw the curve. My ability to draw it is maybe lacking a little bit. Okay, there we go. But I don't know what's going on the left side. So it's possible that my curve could sit up here in the upper left. It's also very likely that it's in the lower left, but I don't know until I actually find a point and I test it. So I'm going to go ahead and test the point -2. All right, I want any point that is to the left of the vertical asymptote. So in this case, -2 works. And I'm going to use, let me go back up to this problem. All right, and I'm just going to label this extra point. All right, extra point. And I'm going to use, like I said, x is equal to -2. So let's see, y is equal to 2 over negative 2 plus 1. So that's 2 over negative 1, or just negative 2. So the extra point is negative 2, negative 2. Let me make sure that my brain is functioning here. It is. Okay, good. So I can use that point negative 2, negative 2 now. All right. So negative 2 is a point right here. And that now tells me that this curve has to be in this lower quadrant because I can't cross the x-axis. I don't have any x-intercepts to cross at. So I'm going to use my asymptotes to curve in and approach, right? Approach the asymptotes, but don't actually cross them. That is a horrible looking curve in this lower part. So let me curve that out a little bit better. There we go. Slightly better. All right. So that's the bits, parts, and pieces for problem number 1. I'm going to go ahead and stop this video and pick up with number 2 in the next video.